Albert Einstein's theory of relativity, as the name itself suggests, is based on the relative position of a person or an object. So, what is a reference frame? A reference frame or a frame of reference is a fixture of points in spacetime that may be used for the purposes of measurements. For instance, I might say I'm stationary with respect to the ground, but I cannot reasonably argue that I'm stationary with respect to the sun. I am in motion as due to the Earth's rotation and revolution. Similarly, it would also be incorrect to infer that the sun is stationary. It is also in motion with respect to the center of our galaxy, which in turn is in motion with respect to the center of our universe. What we tend to conclude from this is that there is nothing such as an absolute reference frame. This also enables us to assume that we can change our frames of reference as per the requirements of particular functionalities and for the purposes of testing. The reference frames dependent on their properties can be divided as inertial reference frames and non-inertial reference frame. An inertial reference frame is the one which has no acceleration acting upon it, and hence it requires no force acting on it as well. It can be anomalously considered to be at rest or to be moving with constant velocity, well as it is also independent of the curvature of time. We can also consider it to be a Galilean reference frame. A non-inertial reference frame, on the other hand, has certain acceleration acting on it and hence has also got some external force on it. Now, it is important to understand that the laws of physics are similar for all the inertial reference frames but vary for non-inertial reference frames. Well, this description might allow us to believe that we can reject the ideas of laws of physics altogether. However, imperatively to make for this aberration, there are certain external forces added to the object in the non-inertial reference frame. These forces are known as fictitious forces. Well, all these fictitious forces are having mass directly proportional to the force. This may seem familiar with Newton's second law, where force is equal to mass into acceleration. These fictitious forces for a circular movement may be known as centrifugal forces, while for a rotational motion are known as Euler's force and at certain time also as Coriolis force. The fact that force is directly proportional to mass may also intrigue us to know that gravity is also a fictitious force, which indeed is given by the general theory of relativity. It states that gravity causes the space-time curvature, which is also a property of all the other fictitious forces. Fictitious forces are also alternatively known as pseudoforce, D'Alembert's force, or inertial force. In classical mechanics, the objects in distant space are taken to be the frames of reference. It has certain benefits, like the frame of reference is inertial, although it cannot be used for the purposes of advanced calculations. We can now conclude that for relativistic concepts, the frame of reference used causes a great significance.